Okay, pardon the squeaky chair and all the extra noises. My microphone decided to stop working, so I am now going to be just kind of going straight into the computer mic, the laptop mic. So the quality is, I don't know, maybe it's better. Who knows? That wasn't a great microphone anyway. Anyways, you might hear some other outside sounds, so I apologize in advance for that. So today we're going to talk about factoring polynomials with synthetic division. Now, it's kind of essentially what we've been doing. When you divide a polynomial, whether you use long division or synthetic division, you are basically factoring it. The difference is there's this thing called the factor theorem, right, that shows us, and it's kind of an intuitive thing, and you'll see it when I talk about it in a little more detail in a second. But it's kind of an intuitive thing that means that if you can factor something, that means that when you divide it by that factor, you're going to get no remainder, right? It should work out. So that's what we're going to talk about today. That's the premise we're going to work off for these. We're going to get a little more practice with using the AC method and factoring, and obviously because it's in the title, we'll be doing a little more synthetic division. So if you're a little wobbly on that yet, we will hopefully shore that up somewhat for you. So let's get started. All right, we're going to talk about the factor theorem first. All right, so the factor theorem, basically it says a polynomial f of k, right, f of x, has a factor x minus k, so k could be anything, if and only if the remainder of when you divide this by this, so f of x divided by this, is 0. So in other words, that little box at the end of the synthetic division when we do that, so we have our thing that looks like this, and then we got these numbers right here, right, and then you've got this, and then we've got our box. So if this is 0, then that factor that you got your number from, so that would be this, right, works, right? That means it is actually a factor of that polynomial. And so I think operating off that, I think this is another one of those things that will look better just seeing it and doing it. So that's what I'm going to do and stop talking. So at least stop talking about that. All right, so first of all, let's set this up. All right, so remember when we do this, right, we have to remember that we need a factor, we need a number with synthetic division for every single term, right? So I've been kind of doing this thing where I make small little numbers that are for the exponents of our variables, right? So the third one, so then you put your 2 there, put -3 here, put -17 here, and then for 0, it looks like I should have shifted it a little, but that's all right. We're adaptable, right? So we'll take these and move these over a little bit. So we got 1 and 0, right? So that's what they correspond with. And then we have x plus 3. So remember, the trick is to do the opposite of what's here. So if you have +3, we're going to use -3 right here. We're going to put our little line, and then that's our remainder box is right here. Okay, so the way this works, all we got to do is see if when I put this thing in, do I get 0 for my remainder? And if I do, that means it is a factor. And if I don't, and I get a number, that means it's not a factor. And so obviously for this, being precise with this is important. All right, so I'm drawing my arrow here, showing that we start by bringing the 2 down. All right, now it's our series of multiplying and adding, right? So -3 times 2 gives me -6. Now we're going to add that thing, right? These two, -3 plus -6 gives me -9. I'm going to do another multiplication step. -3 times -9 gives me +27. All right, and then +27 and -17 give me +10. And then -3 times 10 gives me -30. And 30 and -30 do make 0. So x plus 3, the short answer would be yes, it is a factor because we have a remainder of 0. And then this answer here, right, this thing you get here has a name, and they call this the depressed polynomial. All right, depressed polynomial. If you think of what depressed means when we talk about mental health, it means kind of down or low, right? And so this is the lower polynomial that you get, lower in the sense that it's actually physically below this. And it's also lower in the sense that when I write it out, right, I get 2x squared. Remember, you go 1 less than what you started with, 2x squared minus 9x plus 10. When you write it out, it's a lower exponent for its leading coefficient. So the degree of this is only 2, whereas the degree of this one is 3, right? Degree is always your leading exponent, right? Your leading coefficient and its exponent. So that's how you identify your degree. So this is a polynomial of degree 3. All right, so a couple new terms are kind of throwing at you here, but nothing complicated, right? So they call this a depressed polynomial. And so when we would write this out, we would say, okay, that means that this is a partially factored form of this, right? So if this is a factor of it, this is your depressed polynomial, what you get as a result of it. And now what we'll do in the coming videos is we'll talk about, okay, if we can get this, then what can I do about this if I want to factor this completely? All right, and so that's what's on board here, and hopefully you see though that this factor theorem it works. It's pretty cool, and it's pretty simple, right? If you understand the ideas behind synthetic division. Okay, going to stop the vid, and we'll catch you in the next.